A and B algebraically and then graph. What is that? Calculator.
Yes, that's what we did on our
Or
calculator.
you're getting two different answers, like x equals and x equals.
Yes, 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 yes.
What is the name of this?
Well, this is more from yesterday. We're not new yet.
Oh, okay.
Remember I told you that's the same thing as y? Okay. Algebraically, if I ask you to find the zeros algebraically, that's what we've been doing, okay? So we haven't really done it in the form of just, you've done it, you just don't know that that's what you're doing. So finding the zeros is putting a 0 in for the y, which there's not a y here, but there is a f of x, which is the same thing as y, right? So if I put a 0 in for f of x, then I can solve, I can find the zeros. So algebraically means setting the equation equal to 0. Setting equal to 0 and solving. You have been doing that. You so far know 2 ways to solve that, and I've asked you to do it both algebraically. How are we going to do that? Factor it, right? I'm going to go through all my steps of factoring this and setting equal to 0. So, was that my pocket? Y'all didn't hear that? It was like a Siri that said, I didn't understand. That kid's phone in my pocket, I think, or else was it you?
I heard it. Oh, no, I was
Hey
going to
Siri.
tell you something that I figured out, but I'll say it later.
Why are you?
I was stepping on it, it fell off though. Okay. What multiplies, and can I shortcut this one first of all? Look at it. Maybe not a shortcut like a difference of squares or a perfect square trinomial, but because the leading coefficient is 1, whatever multiplies to 8 but adds to -6, I can just plug those in. What are they? 4 and 2, -4 and -2.
That's all I'm going to tell you.
Yeah.
Wait, were there any, like, what would DCF?
I don't remember.
I don't think there was, because I was like, second guessing.
All right, x equals 4 and x equals 2. Okay? That's what we've done.
-1.12.
Did you put the equation in wrong on your calculator? Hit y equals again. That's what it is. All right. Now, if you graph this, guys, if you graph this, now also notice this, whenever we were graphing, this is standard form, yes? Say yes, because that's right. Yeah. What form does this look like? When we were graphing, what did we call it? Yes? Intercept form. Why did we call it intercept form? Those are the x-intercepts. So does it make sense as to, but remember we had to change the signs inside the parentheses. Do y'all remember that? What I'm hoping is this is starting to come a little bit more full circle to you as you see this, that they're kind of going hand in hand here. So graphically, if you put this on your calculator, what you should see is you should see a parabola that looks something like this, crossing at 4 and at 2. Is that what you got?
Yeah.
Let's see if I can do it without my It is. So I don't think I'm going to give you, it is, it's all in your calculator. So it would be, some of these are going to be hard. Some of these, you'll get decimals and stuff, and you would just say x equals 4, x equals 2. I was just saying for us together, I wanted you to see that you got the same thing. No matter how you solve. You see what I mean? On a test, if I said solve graphically, I would give you a place to graph it. And you would graph it and you would give me the answer. So you'd say x equals 4, x equals 2, and I would look at your graph to make sure it's crossing at 4 and 2 also, so that you understand. I think I even sometimes say circle the solutions on your graph so that you know. As well, sometimes it's a decimal and sometimes it's a kind of nasty decimal. So it would just depend. All right, so I want to move on from here. I don't ever get real bogged down with graphing. Really, the most important thing with graphing is one, you start learning how to calculate these various points on your parabola, and two, that you see the connection between the algebraic solving and the graphic solving. You know on the graph that where it's crossing the x-axis, those are your solutions to your quadratic. Okay? All right, let's do square roots.
Wait, so if they don't add to the same thing, probably.
What, you don't want to do them? Yes.
So
That hole in your chart.
that's basically. So whenever we solve it graphically, we want to write it graph.
Yes. If I asked you to solve it graphically, if I gave you this and I said solve this graphically, then this is what I would expect.
Wait, what about our solution? Right. X, triangle.
Yeah. I told you to get your sisters.
I think that's
I don't know where it is, but I have.
I'm waiting on batteries.
Is that the phone?
Remind me after class, and I will text Caitlin and ask her if you can borrow her calculator. All right.
Wait, Miss Lee, how do we write the solution?
X equals 4, x equals 2. Thank God that one from yesterday. I was going to give it to you for homework today, but I didn't. Do you want one? You don't need it unless you just want extra practice with it. You want to see it?
Wait, I didn't. Wait, I think it's. But that's not really good.
All right, let's do square roots. Do you have teachers that don't? No, because whenever I do that, then everybody tries to work ahead whenever I explain how to do it, and then they stop me, and I will have already taught it, and they'll stop me wanting me to re-explain. Otherwise, I would. Are you serious?
Yeah, me too.
Okay, but no.
I never did any work on the weekend. Oh, I mean, we got work over break. Over fall break.
All right. Solving with square roots.
This is a whole nother thing.
Remember, the whole rest of this unit is all about what, Jonathan?
Wait,
Tell
no,
us.
like, should I put this on a different page?
Okay, this is new. It's a new one.
Okay, so I should put it on a different page.
All right. Before I teach you how to solve with square roots, I need to review you on some square root properties. Oh no. It's the Gina. All algebra 1. We'll probably, I do a lot of the Gina with the algebra 2. Two properties that you just have to know. One is, if you are multiplying, then I can split up the multiplication under separate radicals. That works every single time. Same thing with division. If I am dividing, I can split this up as the square root of A over the square root of B. So you are fixing to see, I hope do y'all remember working with radicals? Okay. We're going to use these properties to simplify our radicals, okay? And here's how we're going to do it. When we have, first of all, tell me what a square root means. What does a square root do?
It has to be times by the same number.
Wait, it's like the opposite of like an X or a square.
It's the opposite of squared. Okay.
Something that can be divided into two of the same number. And it's like two, some number doesn't.
The same number 2 times, right? So I feel like we've talked about this a little bit. Didn't we do? And I said, what are perfect squares? And we listed them out. Okay. That's what we're going to do today. That's what we're going to do today. So the square root of 9, all right, guys, the square root of 9 would be what?
Right.
You're half right.
Square. Square.
Why did I do that?
Because if two negatives.
You told me 2 things that multiply to give you 9, 3 and 3, but I say also -3 and -3. Okay? Make sure you pick up those negatives. Now, what happens if I have something like this?
You have to do like this. Yeah.
Yes. So tell me your thought process with that. That's right. I always tell my kids to do this, but you're splitting them apart. What I'm doing is I'm looking under the radical, and I find I'm looking for the biggest perfect square factor.
Like 9 squared.
So here's what I want to do. Of all the perfect squares you know, and if you're not used to this, make yourself a list of perfect squares off to the side. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 36, 49, 64, 81, 100, 121, 144, 169, 13, 14. What's 14? 196, that's right, they're just inverted. And then 225, at least be familiar with up till that many, at least up through 15 squared. So what I want to do is I want to look at that list and I would say, what's the biggest number from that list that I can divide 18 by? 9, right? 9 times what is 18? 9 times 2. So I use that property that says that I can split them up. And this, the square root of 9 is 3. So I have 3 times the square root of 2. The plus or minus goes in front of everything. If you throw, this is not the same.
The 9 turns into.
Because 3 times 3 is 9. It can be
If it
some.
does have a square root, it just goes down.
Yes.
But if 2 had a square root, it would just be the answer.
Yep. Yep.
If both of them have square roots, that's right.
Right. It would. Right. All right. This does not equal. You cannot throw that plus or minus in front of that root 2. These are 2 different problems. The first one is 3 times root 2. The second one is 3 plus root 2 and then 3 minus root 2. They are different. Do not do that. Okay? I'm using very basic, simple examples right now, but we're going to get a little more complicated in just a second.
Is it simple?
I like square roots when it's like one number.
All right. Who asked me to pause here? Boys. Simplify. Mark said go.
Oh my God.
Which one? Don't go yet. Don't go yet. Let me give you a hint as you're going. What is that 3 doing to that radical? What's the operation between it's multiplying? Keep that in mind. It's multiplying. To anything outside, yes. So whatever you, like, for instance, if this one had a 2 outside before I started, then this one would be 6 out. It's being multiplied out front to anything you pull out. So if you pulled out a square root of 9 and it became 3, then you'd have 3 times 3 out front. Is it a decimal? You may not use a decimal. All right, so listen, the point of this is that our answers are exact, meaning they're not rounded at all. It's kind of like the difference in writing 1/3 and 0.33333, because 0.33333 is not as accurate as 1/3. No.
Is it 72.1?
No. No decimals, no decimals.
Plus minus, plus, or positive or negative 51 square root of
51. I don't know. What's your perfect square that you took out? I don't know.
17.
17 is not a perfect square. Oh, 17 squared? What is 17 squared? 289? So you're saying you did 289 and 2. Agree or disagree? I stopped at 15. I know. I'm sorry. I stopped at 15. Look at this number. Now, okay. The square root of 289 is 17. You don't.
I thought it was 9.
I get a break. Never been more shocked in my life. You can't have it.
No decimals. No decimals. So look, here's what I do on these whenever I just don't know where to start, right? None of these numbers work, but I need to make sure that there's not one a little bit bigger. So this was 15 squared, so then I would try 16 squared. Then I would try 17 squared. Generally what I'll do, I usually start the biggest before I go down any. What is 16 squared? 256. But when you got to 17, you saw that it was divisible by that 17 squared. Yes. Simplify. Mark said go. This one's easier.
Wait, so what are we going to use?
I haven't showed you how we're using it yet. Everybody keeps asking me that. I don't know the answer. Are you still drinking medicine balls?
Yeah. Good. Actually, well, this one and this one are sitting for me. If I do 6 no,
Where are you confused at? Okay. Try this one first before the last one, because the last one I think I confused you with the number 2. What are the 2 numbers that you use that has to be a perfect square?
okay, wait.
Got it all.
That's what I got.
No, chicken nuggets. I think it's 33.
Oh my gosh, I really look at the front. I actually realized I have to.
Yeah. Okay. What'd y'all get? What do you?
Or plus or minus 30 square.
Okay, tell me what perfect square you took out. 36. Did anyone use something other than 36? Okay, I'm glad y'all said that because I want to do it whenever I use 9 and show you what happens. All right, so this is 5 times 6 times the square root of 2, which is 30 root 2. That's right. Now, what if I hadn't used 36? What if I hadn't picked the biggest one? You'd have to do it again. So if I use 9 and 8, that would be 5 times 3 times the square root of 8, 15 times the square root of 8, and then I'd go, but wait, there's another perfect square I can divide that radical by. 4. 4 and what? 2. So now I've got 15 root 4 root 2, which is, you see, it's just extra work if you don't pick the biggest one, but it's not necessarily wrong. You did. This is Algebra 1 review. I haven't got to the Algebra 2 stuff yet. You may have. All right. Kylie, did that help? Okay. Now, certainly may.
No.
Which, the splitting up? You are constantly looking for a number off that list that you can divide what's under the radical by. That's your goal every time. So off that list I had, 36 was the biggest number that would go into 72 evenly. 36 times 2 is 72. Or 9 times 8 is 72. When I get here, 4 times 2 is 8. I'm splitting it up into two different numbers. One of them has to be a perfect square. I don't, I'm out right now. I'm waiting on batteries. All right. Oh, what? All right. We haven't done the division thing yet. Now watch. I've got the square root of 4 divided by the square root of 3, yes? The square root of 4 is 2. Now, square root of 3 is in the bottom, okay? So, I can't have a square root in the bottom. Never, never, never can you leave a square root in the bottom. So what do? Instead of doing that, I have to bring it up. How do I have to bring it up?
You have to make out of 1.
I have to do what's called rationalizing the denominator. And to do that, I take the bottom. Now, this works because whatever you do to the top, you can do to the bottom. So if I multiply the top and the bottom by the same thing, that's like multiplying by a 1, yes? So what I'm going to do is, So what happens if you square it is if you do this, then you're multiplying the top by 2 and the bottom by square root of 3. You've got to do it by the same thing. So you're thinking right, but what you have to do is you have to multiply by the square root of 3 in the top and the bottom. Now it's only going to be the radical part, okay? It's not going to be the whole thing. So if there was like a number in front there, I'd only take the radical part and not the number in front. So what I mean by this is, this becomes 2 root 3. What happens on the bottom? What is the square root of? It's 3. Now everybody always gets confused about that, and I'm not real sure why. But if you want to think about it as putting them together, you'd get the square root of 9. But anytime you have the same thing that's being multiplied together, you get whatever was under there to start with. That's just what happens. Okay, because this would be x squared. Squared and square roots are opposite. I would get 3. Throw the plus or minus in front, and I am done. Yep.
So whatever's on the bottom will always be the
Yes. Then you would just take the square. So if it was like the square root of 4/9, that would just be 2/3, and there's nothing else you have to do. It's only an issue when you end up with a radical. Radicals are okay up top. They're not okay in the bottom. I could leave it like that. Yes, yes, yes. Oh my gosh. Okay. I think you have enough information for me to be able to move forward. Yes, 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 yes. I woke up with a little, I have a little carrot over there. All right. When am I going to use this, or how am I going to use this? Now, remember the whole point in everything in this unit is that we are solving quadratics, right? Okay. Are you laughing at me? Oh, I thought I was doing something stupid. Okay. If I have something, we're going to start out really, really easy. If I have something that looks like this, so far the only way you know to solve the quadratics is if I factor and set each piece to 0, yes? Or what's the other way we talked about? Graphing and finding the zeros, right? So this is another way, but this does not work every time. Now I want you to look at this for just a second. Here's the stuff. Here's the whole reason we were simplifying. And from this point forward, you can't take it. From this point forward, if you end up with a radical, you have to simplify it, okay? Period. You always simplify it. If you solve something and you get an answer like this, you have to split it up. I'm fixing to show you. Just know that you have to do that, okay? If you end up in that situation, you have to do that. Y'all okay? All right. Now, my next question to you is, if you had something, let's say this squared was not on here. And I said, Julian, solve that for x. Minus 8, right?
Wait, but then it wouldn't be a quadratic.
Okay, it's not a quadratic, but I'm getting you to something right now. How do you know that you minus 8 first? Okay, but how do you know there's also a 7 hooked to the x? How do you know that you do the 8 before the 7? You're close. We're doing it backwards, right? PEMDAS is for simplifying, right? The opposite of simplifying, and I hope when you took Algebra 1, somebody taught you the order in which to solve equations.
Oh, yeah.
And that we go backwards PEMDAS, right?
I never thought about that.
We go SADMAP. SADMAP. Okay. Parentheses, dead last. Okay, we're going to do, if there's any parentheses, those come last. But we're going to work our way addition, subtraction first outside of parentheses. Multiplication, division outside parentheses. Guys, it's really hard to consistently talk over y'all. Then exponents and then parentheses, okay? So, looking at this, that is why I subtract first. Okay? That's the order in which we solve. Because simplifying goes this way. Solving goes this way. Solving is the opposite of simplifying, okay? If it says simplify, it's PEMDAS. If it says solve, it's StatMap. Okay, now, I will say this to you over and over and over and over and over. If you see only one x in your equation, I don't care what exponent is on it, I don't care what else is in it. If you see x written literally only one time in the equation, your job every single time is going to be to StatMap your way out of it. Okay? Don't try to do anything else. Don't try to factor it. Don't try to graph it unless I tell you to. StatMap your way out of it, okay? Because everything on your test, I'm not going to always tell you which method to use. You're going to have to decide the easiest way to solve it. For one like this, the easiest way to solve it is always going to be StatMapping if you can. Okay? What do I mean by that? Let's do it. That was a cough, but thank you. Okay, so if I need to get x by itself, right? Addition, subtract, okay, subtract 8, subtract 8. So now I have 7x squared equals 7. Now what?
Divided by 7.
You divide it by 7. Don't do that exponent first. Now this would be different if it looked like this, okay? But it doesn't look like that. Instead, it's this way. So I got to do the inside parentheses would be last if it looked like this. But because it looks this way, I'm going to divide by 7 first. X squared equals 1. Now, how do I get rid of the squared? Square root both sides. What is the answer? Which is plus or minus 1. Do you understand why it's so important I get my 2 answers now? Because graphically, what is it I'm finding? On a graph, your x-intercepts, how many are there? 2. If you leave one of the plus or minus out, you've left half the answer off, right? So it's 1 and negative 1.
Wait, so we should solve that same thing like the way we've been doing it?
Yes.
So will we have to do it that way?
It depends on the way the equation looks as to which way you can do it. So we'll see some of both.
You could just like grab it that way. Or you want to get.
Okay, you could, but you're doing too much work when you do it that way. If you equaled it to 0. Because if you equaled it to 0, you'd have 7x squared minus 7 equals 0. Then you'd take out a 7. Oops. And then you'd have a difference of squares. And then you'd set each piece to 0. And you're getting into way too much work whenever you do it. It's not that it wouldn't work, it's that you don't have to. What you got, Max? Well, if it's 7x plus 8, that's a linear equation. You still go backwards and solve it that way too. No, only with a quadratic.
So we'll know what to do whether it's simplify it or.
Yes. You leave it. Leave it square root 2, but plus or minus square root 2. Right. Yes, always. Always. Did y'all hear that? Do we have to simplify the square root? Yes, always. Oh, thank you. Yeah.
Can we do them when we have to
Get an answer where it's like 3.
3 root 2.
Yeah.
Yes. Yes.
Oh, wait, are we not done yet? That was the easy. What?
You feel like we're learning a lot? So we're still Algebra 1 right now. That's why we're going faster. Y'all did this in Algebra 1. Now I will tell y'all, we do a lesson a day. We do a lesson a day. Like, Yeah. Well, yeah, and even then, we usually do still do them. At least part of one. Oh.
I thought.
All right, just stop it. Y'all worried ahead of time.
I'm sure I got on my bed. Wait, don't you like go on
I don't know. Yes. Sad math every time. And I know that. All right, guys. How do I know it's a sad math problem? I know it's a sad math problem because when I look at the equation, there's only one x there. That's right. That's right. What was 0? All right, guys. My table at the back is y'all are so distracting. Like y'all are distracting me, so I know y'all are distracted, and y'all cannot be paying attention. I've got a little group here that's talking a lot, but this table at the back is really distracting me. I need y'all up here with me. Okay. All right. Now, what were you saying?
like when we were scattered. It was like I don't know. It was like we were missing something. Maybe that was the last thing that we did. We were missing something.
Okay, that's when you're
so then we
missing
put
a B.
0.
When you're missing a B in the
Yeah.
middle. Yes, and that's what this is. Yes, you're still missing a B in the middle, but always look. You're looking to see how many X's are in there. If there's only one X, don't try to do anything else other than sad math. For some of them, yes.
Yep.
Would you split? Oh, yes. No, not 20.
How's it not?
How is it not 20?
That's what I got.
Okay, everybody wait. Dividing by a half is not multiplying by a half. It's multiplied by 2. We don't divide by fractions, we multiply by reciprocals.
So it's double, not half.
I forgot about it.
Dang, bro, we forget.
So it's -8. It's 8.
Okay, when you get to this point, do not divide by a fraction. Does everybody hear me? Right, because who can keep up with something divided by a fraction? That's like double division. Instead, we take the fraction, we flip it over, and we multiply, because I'd rather multiply than divide all day long anyway, right? Okay, right, because that's right. Okay, negative. Reciprocals multiplied together cancel out. Yay! Okay. I don't have to. You don't like my dances?
I did.
Oh.
You gotta be like,
He was getting,
excuse me?
he was getting.
Oh, wait. What? Okay, good. I was like, wait, why is it negative?
All right. So what's the square root?
Can I solve it by myself?
No.
Real quick.
Here's where. This is why I took some time in the beginning, guys, to go over how to simplify this. Right? You have to split it. How do you know you have to split it?
I don't know how I know I did it. It's a big number. I said, oh, it's a big number.
There exists a perfect square that I can divide 80 by.
16.
16 and what?
5.
4 square root 5.
Plus or minus 4 squared root of 5. Max, this is what you were asking just a minute ago. Can it have a radical in the answer? It absolutely can. Don't give me a decimal for this. I'm going to mark it wrong. Okay? Jonathan, how do you know? How do you know that you can sad map it?
Yeah, what she said.
Yes. When there's only one X in there. All right. Y'all are.
What did you divide?